Here is an example exam question of a combinations question. It says tickets for a concert are given out randomly to a class containing 20 students. No student is given more than one ticket. There are 15 tickets. Find a number of ways in which this can be done. We know it's a combination question as it is asking us to find the number of ways of selecting 15 students out of 20 students in order to give them the tickets. So here, our N would be 20 as there is a total of 20 students, and our R would be 15 as only one student can get one ticket, hence only 15 students will be able to get tickets. So using combinations, you get 20 choose 15, or in other words, 20 factorial over 20 minus 15 factorial, which is 5 factorial, times 15 factorial, giving us 15,504 ways that this can be done. Part 2 of this question has a condition in the number of ways that the tickets can be distributed. It says there are 12 boys and 8 girls in the class, and that 10 boys and 5 girls get tickets. That means our N here for the boys would be 12, and R is 10, as only 10 of the boys get tickets. And for girls is 8, and only 5 of the girls will get tickets, which is represented by R. So our final equation will be 12 choose 10 times 8 choose 5, giving us 3,969 ways in which this can be done with the condition that 10 boys get tickets and 5 girls get tickets. The third part of this question is asking how many ways can the tickets be distributed on the condition that all the boys get tickets. There are a total of 12 boys, so 15 minus 12 gives us a leftover of 3 tickets. That means 3 of the 8 girls will get tickets. So our equation would be 12 choose 12 times 8 choose 3. As all the 12 boys will get the tickets, but only 3 of the 8 girls will get the tickets. And that will give us 56. So there are 56 ways in which this can be done. Here's another example examination question. We know it's a combination question as it has the word groups. The question says 7 children have to be divided into 2 groups, one of 4 children and the other of 3 children. Given that there are 3 girls and 4 boys, find a number of different ways this can be done if there are no restrictions. If there are no restrictions, that means regardless of the gender, there will be a group of 3 children and 4 children. And our N is equal to 7 as that is the total number of kids. So we can start by making a group of 3, which would be 7 choose 3, which is the same as 7 factorial over 7 minus 3 factorial, which is 4 factorial times 3 factorial. Or we can start with a group of 7 choose 4, and that is 7 factorial over 7 minus 4 factorial, which is 3 factorial times 4 factorial. As we can see, the answers are the same here. Hence, it doesn't matter which way you pick first, as order doesn't matter in a combinations question. So the answer is 35, and that is the number of ways this can be done if there are no restrictions. Part 2 of the question is asking how many ways can this be done if all the boys are in one group. If we remember correctly, there are a total of 4 boys and 3 girls. If all the boys are in one group, that means they all must be in the group of 4, giving us 4 choose 4. And then the remaining 3 girls must be in the group of 3, which is 3 choose 3, which is just equal to 1. So there is only one way this can be done. The third part of this question is a bit more tricky. It says 1 boy and 1 girl are twins and must be in the same group. So they will either be in the group of 3 or in the group of 4. So because 1 boy and 1 girl, the twins, are already guaranteed to be in the group of 3, that means 7 minus 2 gives us 5. Only 5 other people could potentially be in this group. So here our N is equal to 5. And because the twins are already guaranteed to be in this group, only one more person can join this group to make it a 3. So 3 minus 2 is equal to 1. Hence our R is equal to 1. So if the twins are in the group of 3, it is equal to 5 choose 1. And the group of 4, N is still 5, as the two children who are twins are already guaranteed to be in this group. But R would be equal to 4 minus 2, which is equal to 2, as only 2 more people out of the 5 potential people can join this group, giving us 5 choose 2. Here are the 2 different possibilities of the twins being in the same group, whether they're in the group of 3 or in the group of 4. And so we sum up the possibilities, giving us 15, as 5 choose 1 is equal to 5, and 5 choose 2 is equal to 10.